All right, the last logarithm applications example deals with population growth. Population growth and population decay can both be really very prevalent use for logarithm and exponential equations. Seeing how fast a city is growing and be able to do things with that is really important to businesses and just the way the city runs and stuff like that. So, and the economies. So let's see. In 2007, the population of Pakistan was 164 million. It's expected to reach 250 million by 2025. And so what we're going to do here is find a value that would make this equation work. Okay, so we need to find this a value. What's the base of our exponent going to be to make this equation work? And once we have that value, we can do stuff with that equation. Okay, so where we need to start with this is kind of filling in some values. So p of x, that's a certain population that we want to reach or have. And then here's the 164, that's the base population that we have the data for. You see up here, there's this a value that we're trying to find, and x is time. So it says x is the year. And then here's this base year that we're comparing it to. So the 164 and the 2007 come from information from the problem that we have data for. And then the x and the a come from where we're trying to get to. Okay, so we know we want our population to be 250 million. That's what is expected to be. So that's our p of x. And then x, all right, it said x was the time, is 2025. So I'm going to fill in those two values. So 250. That's 250 million, but the data is in millions, equals 164, that's times a to the x. Now we know what x is, 2025 minus 2007. All right, all that's together. So we want to get, solve for a, so we need to get rid of this 164. Kind of like we were doing in the last problem. We'll get rid of that number. So let's see. 250 divided by 164. All right, 1.52. Maybe we can say, let's go to the thousandth, 1.524. It's really not a good idea to round in the middle of a problem, but we can't do much about that at that point. And then a to the, let's see, 2025 minus 2007 is 18, so a to the 18th power. So we can take the 18th root of this to figure out what a is. That's kind of weird. 18th root of this number. Now it's nice when I go to type this in my calculator, I can actually use that whole number that the calculator should have kept hold of. So now I'm not rounding anymore during the middle of the problem, even though I rounded when I wrote down something. I'm going to let it use all of this value here when it does the math. So 18 math. Oops. Math button, root 5. So 18th root. And it's second answer. And it'll take the 18th root of that number that I just got. So 1.02346. All right. So I'm going to store that as a, since we wanted it to be our a value. So hitting storage and then alpha a. There you go. So now my calculator knows what that number is. But I can write it down approximately for when we're doing math. So, but it's 1.024. We'll say when I write stuff down, but I'll let the calculator hold on to that. Okay, So now we have this value, so what we're going to end up doing is rewriting this equation when we do other things. Okay, so it says predict, or I guess I could do that now. So what we have now is this equation that p of x equals 164 times 1.024 x minus 2007. Now, one thing you got to be careful about is when you are thinking about this, you got to remember that these two numbers cannot be multiplied right now because this 1.024 has an exponent on it that we don't know because of this x. Okay, so you kind of need to think about this as being held off. This 164 and this thing here can't interact, okay, until we know what x is. All right, so second problem. Predict the population of Pakistan in 2015 and compare your prediction to the estimated value of 191.7 million. So in 2015, they took census data or whatever and got this data. So we want to see how good our model is, basically. And so in 2015, that's an x value. And then here we have, we'll save this number for later. We're not going to use that. So we're going to use this value of x to figure out what's going on here. So P of 2015 equals 164 times 1.024 to the 2015 minus 2007 power. Of course, that's 164 times 1.024 to the 8th power. So you can either type this into your calculator or you can use the storage value that you have from before and you can see what you get. So 164 times alpha A to the 8th power. Might be interesting to see how it compares if we do the just the rounded value. 1.024 to the 8th. It's not going to be that much off, but you can see. So using the exact number, we get 197.8 million. The rounded number gives us 198.3 million. So it's 500,000 off, which is a lot of people would be off. So I'm going to go ahead and use the whole value here is 197.8 million people. So they wanted us to compare that to, so how good is our model, compare that to the actual data. So let's subtract that. So that's a comparison idea, subtracting two things, 197. So let's see, I give this, 1, 6. So we are off by 6.1 million. Which is a pretty good chunk to be off. But again, just an approximation when we do get an answer. All right, last part of this problem is to estimate when the population can reach 212 million. So when does that happen? They think by 2025 it'll be 250 million. Maybe 212 holds some significance for something, so they're asking when could that happen. So what they're giving us here is this P of x value again, like the end population value. Okay? And then we're trying to figure out when, so that's we're trying to figure out what x is, or our t, but t in this problem is x. So 212 equals 164 times a to the x minus 2007. So we need to solve for x. Remember, a is this value here that I plugged into the calculator. So I want to solve for x. So I want to get I want to get x by itself. So 164, get that out of there. So 212. So 1.292 is 1.293. But then let the calculator hold on to that number. Don't clear that out. But I'm just going to approximate it down. So whereas pretty similar problem where we are at with the interest problem. We need to solve this for x, but we can't do that because it's in the exponent spot. So we're going to turn this into a logarithmic equation. So we're going to go log base a, or which would be log base 1.024 of 1.293 equals x minus 2007. So of course, to solve this equation for x, we want to add 2007 to both sides. So where that gives me is x equals log base a of 1.293 plus 2007. And so of course this here needs to be turned into or changed base formula because I don't know what log base a is. So this is going to be rewritten as log of 1.293 divided by log of a, and all of that plus 2007. So let's go to the old calculator for that. So here's this number that I was approximating. So I want to take the log of that. So log second answer, close those parentheses, divided by log alpha a, bring in my constant that I filled in, and I'm going to close those parentheses again, and then plus 2007. So 2017.96, so really close to 2018. So now. So Pakistan should reach 212 million people by this year, according to our model. All right, so that's it for applications of logs. Here is the homework assignment. Sorry to be gone yet again. Hopefully this is the last time for quite a while. Have a good rest of your Wednesday, and I'll see you Friday.